Continuing with our curve sketching example, we're going to go through one more example that is somewhat more sophisticated. This time we want to sketch the graph of the function x cubed divided by x squared plus 3x minus 10. It's a rational function, and so the first problem is to find the domain. And here, if we factor the bottom to see where the bottom is 0, it factors as x minus 2, x plus 5. The top, x cubed, is not 0 at 2 and not 0 at negative 5. Therefore, we have vertical asymptotes x equal 2 and x equal negative 5. On the other hand, f is of the form of a polynomial of degree 3 divided by a polynomial of degree 2. We know that in that case, when the top is of degree 1 more than the bottom, we have a slant asymptote. So we are looking for the slant asymptote by long division. Specifically, we divide x cubed by x squared plus 3x minus 10. To start with, we divide x cubed by x squared, and we obtain x. Multiplying x by x squared, we get x cubed. By 3x, we get 3x squared. By negative 10, we get negative 10x. Then we subtract the result to x cubed. So we get x cubed minus x cubed, no x cubed left. 0x squared minus 3x squared gives me negative 3x squared. And 0x minus negative 10x gives me positive 10x. Now this is of degree 2, so it is not of degree less than the degree of the divisor, so we have to iterate. So I divide negative 3x squared by x squared, I get negative 3. Multiplying negative 3 by x squared, I get negative 3x squared. By 3x, negative 9x, and by negative 10, positive 30. Again, subtracting what I just obtained to the line negative 3x squared plus 10x. The x squared cancel. Then I have 10x minus negative 9x gives me 19x, and 0 minus 30, negative 30. In any case, the slant asymptote has equation y equal x minus 3. Now that we have all the asymptotes, we're going to look for the intervals of increase and decrease, and that depends on the sign of the first derivative. So we have to differentiate the function. The function is a quotient, so we use a quotient rule. The derivative of the top is x cubed, so the derivative of the top is 3x squared. I multiply that by the bottom unchanged, x squared plus 3x minus 10. Then subtract the derivative of the bottom, which is 2x plus 3. Multiply by the top unchanged, so multiply by x cubed. All this is divided by the square of the bottom. You see that we can factor x squared in these two terms, and it is multiplied by 3x squared plus 9x minus 30 in the first term, and by negative 2x squared minus 3x in the second term. Simplifying the second term in the product at the top, we obtain x squared multiplied by x squared plus 6x minus 30 divided by x squared plus 3x minus 10 squared. Now the zeros of f prime are 0 and the zeros of x squared plus 6x minus 30. You can try to factor and you'll probably quickly realize that it's not so easy, so we can use the quadratic formula to find the zeros. And in that case we get negative 6 plus or minus the root of 6 squared plus 4 times 30, all this over 2. And this simplifies as negative 3 plus or minus square root of 39. Now f prime is of the sign of x squared plus 6x minus 30. This is because the factor x squared in front does not influence the sign because it's always non-negative. And the denominator is also a square and therefore also non-negative and does not influence the sign of the function either. So f prime is of the sign of the quadratic function x squared plus 6x minus 30. Because the coefficient of x squared is positive, the graph of this function is a parabola that opens upward. We know what the x-intercepts are. it's negative 3 minus root of 39 and negative 3 plus root of 39. Because it's a parabola that opens upward, it's going to be negative between the roots and positive outside of the roots. So now we can try to build a table to see the change of sign in f prime and interpret in terms of increase and decrease. So the first thing we're going to put in the table is the fact that we have vertical asymptotes. We have an asymptote at x equal negative 5 and another one x equal 2. So I mark these vertical asymptotes with a double vertical line. Then I have seen that f prime changes sign at negative 3 minus root 39 and negative 3 plus root 39, so I'm going to place these two values in my table. And I know that the derivative is negative between these two numbers and positive otherwise. In terms of increase and decrease, well, first the derivative is 0 at these two values and also at 0 because we have the factor x squared. In terms of increase and decrease, this is the interpretation of the sign of f prime, and that gives us a local maximum at negative 3 minus root of 39, and this maximum value is obtained by plugging negative 3 minus root of 39 in the original function, and when you do that you get an approximate value of negative 16.6. On the other hand, we have a local minimum at negative 3 plus root 39. To get this minimum value, we plug negative 3 plus root 39 in the original function f, and in this case we get approximately 3.3. Before we can sketch the graph, we need to look into the concavity of the function, inflection points if any, and this depends on the sign of the second derivative. So we have to look for the second derivative, but you see that the first derivative is already a little complicated, and we're going to differentiate it with a quotient rule. So it's going to get ugly. Okay, so f prime is x to the fourth plus 6x cubed minus 30x squared over x squared plus 3x minus 10 squared. Now we differentiate that with a quotient rule. So I obtain derivative of the top, that's 4x cubed plus 18x squared minus 60x, multiplied by the bottom unchanged, so that's this x squared plus 3x minus 10 squared. Then I subtract the derivative of the bottom. The bottom is the square of a function, so I have to use the chain rule. I get 2 times the function multiplied by the derivative of the function. So in this case, 2 times x squared plus 3x minus 10 multiplied by 2x plus 3. All this has to be multiplied by the top unchanged, which is x to the fourth plus 6x cubed minus 30x squared. All that stuff is over the bottom squared. The bottom was already a square, so I get x squared plus 3x minus 10 to the fourth. You see that in this, I have a sum of two terms, of two products. In the first product, I have a factor x squared plus 3x minus 10, and so do I in the second product. So I'm going to be able to factor it out. Additionally, in the first factor of the first product, you see that I can factor out x. So can I out of the last factor of the second product. So I'm going to factor out both x and x squared plus 3x minus 10. If I do that, in the first product it is multiplied by 4x squared plus 18x minus 60 multiplied by x squared plus 3x minus 10 because I add x squared plus 3x minus 10 squared. In the second term, it's multiplied by 2 by 2x plus 3, so together that's 4x plus 6, and also by x cubed plus 6x squared minus 30x. Multiplying things through, we get this horrendous expression, but you see that in this horrible sum, after multiplying things through in the parentheses, we get, for instance, 4x to the fourth minus 4x to the fourth, so the x to the fourth cancel out. For the x cubed, you have 12x cubed plus 18x cubed, that's 30x cubed, but then we subtract 24x cubed and we subtract 6x cubed, so the x cubed cancel out as well. And overall, after simplification, we get this x times x squared plus 3x minus 10 multiplied by 30x squared minus 180x plus 600, all this over x squared plus 3x minus 10 to the fourth. Okay, so that's a simplified factored expression for the second derivative. Now what is the sign of this 38x squared minus 180x plus 600? Well, fortunately it does not change sign, because if you calculate the discriminant for this quadratic function, in other words, what you would put inside the square root in the quadratic formula, we obtain a negative number, specifically negative 58,800. So because it's negative, it means I cannot put this value in the square root. In other words, there is no real zeros for this function. So this function doesn't take the value 0, and it is 600 at x equals 0. That tells me that this function is always positive. So it doesn't influence the sign of the second derivative. The bottom, x squared plus 3x minus 10 to the fourth, is a power of 4, so it's also always positive. So that means that the second derivative is of the sign of x multiplied by x squared plus 3x minus 10, and the second factor factors further as x minus 2, x plus 5.